Hello and welcome. My name is Srinivas, and today let's talk about CICD. In other words, what is continuous integration and continuous deployment. Welcome back. Let's talk about CICD. So what is it? So CICD is a process of continuous integration and continuous deployment. Let's take a look at continuous integration first. So continuous integration is a process in which you can have multiple developers or multiple teams working on on the same code base, and you can have in each and individual developer or teams create pull requests or fork them and then merge them back into the main repository. And merging back into the main repository would be eventually happening into the main master or the default branch. The default branch would be where we would take the code and call it like, this is the source of truth for all our code or all of our intellectual property. And once that code is committed and merged, what we would do is we would trigger pipelines or different test cases or suites of code, and they would start running build and release operations for us. This would be automated, and in this way what it would help us alleviate the pressures of having individual teams and developers to work and coordinate towards releasing code on a scheduled basis, as against to multiple teams working on the same code base, and those changes can be rolled out on a minimal increment. Like, okay, there is developer A finished making a change to X version of the code repository, and now we have a new artifact that we want to create. So that change is merged into the default branch. Now we'll take that artifact, take that changes that we have made to the default branch, and then trigger our code pipelines, which will do our build and release and testing and deployment. The build and release and testing part together can be combined, and to an extent, or it could be stretched a little bit to call it continuous testing, but to an extent could be clubbed together and called as continuous integration process. So what happens there is we take our code that we have merged into our default branch, and we trigger that pipeline, which would take the code, the latest code that is being merged, and it would create an artifact with it. As an example, okay, we have a Java repository and we made changes to it. Okay, we run a certain set of commands using our Java binaries, and then create jar files, which could be used as end target deployable code resources, right? So we take the code that has been merged, which is in plain text, and then we create a binary out of it in this case and create jars. Once that artifact is created, we have to make sure and ensure that the code which we are going to release or which we are going to take further in our process is tested, validated, and it doesn't have any regressions, doesn't have any changes that could impede our operations in any way. It doesn't need to be rolled back. So rolling back fast is a good option, but it's not really ideal in every scenario. So we could have our test cases run against that piece of code, which could be run on a wide variety of ways. Let's take another example as against to Java. So let's say we are running infrastructure as code tools like Packer, and we're creating an artifact. In this case, we're creating a machine image, like AMI would be the machine image for Amazon. And we're creating that machine image, and that is a part of our process where we committed our code. The build process created a machine image using Packer, and then we deployed it to Amazon account, and the artifact is deployed now. Now we want to take that machine image and we want to run a certain checks on it. Let's say we have a bunch of scripts that would go and check if certain things are installed and they are of a certain version, and certain test cases are supposed to be run, and we want to report on that. So that is where we would take that artifact and we will run our test cases against it. We want kind of a dependency on that process so that one doesn't get lost on the other. So that would be a continuous testing part of the process. Now we have tested our code, we have validated it, we have created our binaries or an artifact. We have validated it, and the code is ready to be released for our end users, because we have all the latest and greatest things to provide to them. So this is where the continuous deployment part of the process comes in. So continuous deployment is the process in which we take the code or take the artifact that we just created, tested, validated, and approved using the processes or using automation that we have put in place to saying, okay, this is a copy we are ready to roll out. And then in an automated fashion, we roll out our deployments. using continuous deployment process. So in this case, an example, let's say we have created a jar file that is sitting in our artifact repository. Then we create a Docker image out of it, and that Docker image needs to run on a certain system, let's say ECS as an example. And so we need to run our deployment system so that it would take the latest jar Docker image that we created and pushed into our registries and then apply that. So we need to have automation that does that for us. And then once that automation has executed, our code would be the code that was committed into our main repository, which in this example that we discussed is like, okay, we have developer A committing changes to our main repository, or main branch, changing a version of our one of the binaries. That is, the artifact is created, it's tested. Now we have rolled it out to our end users by using tools like infrastructure as code tools like CloudFormation or CICD, using the infrastructure as code tools like Terraform. And then we roll that change to our end users. Now, this case, the whole pipeline would have made at the end effect of the whole pipeline would be like the little change that was made in the first stage, which was rolling out a new version, has already been applied to our end users and made available to our end users. But other developers can keep continuing working on their changes, and their changes would be would be rolled out one after the other, just like this individual change was rolled out. This is one of the main advantages of CI/CD pipelines, as against to in the previous iterations of trying to roll out changes. Changes had to be batched, and then they had to be released on a certain schedule. And if one of the changes that multiple developers were working on had an issue or needed to be rolled back, then there had to be some work done on rolling back just that change, and not having regression to other changes that were being added to our release. This makes it more agile in a way, and it allows users to roll out changes in a much frequent fashion, in a much comfortable and a confident fashion, and does help increase the velocity of teams and provide features to our end users in a much more convenient way and basis as against to staggering them. Let's take a look at a demo and see how we would implement a CI/CD pipeline. Let's take a look at the CI/CD example. In this case, what I've done is I have checked out or forked a repository from GitHub, which is a simple Hello World application. It's a sample application, and the application here has a route, and once you hit that route in Flask, it says Hello World. Right? It's a very simple application. I have added some workflow files in GitHub and GitHub Actions, so that what we can do is we can try and see look at a very simple example of CI/CD pipeline. So if you look at the screen, we have 3 stages or 3 jobs here which are triggering one after the other, and we can take a look at the code and see further on this. In this case, we have a CI build process. What the CI build process does is it takes and it waits for changes to happen to the main or the master branch. And once those changes happen, it takes those changes, it creates an artifact and uploads that artifact to the artifact repository. Right? In this case, the artifact repository is a package or an artifact created on GitHub Actions. And after that, it successfully completes and it triggers the next phase. Next phase is the CI test. The CI test phase is it goes and checks if a certain test cases are met. Since this is a very simple application, what we're doing here is we are going and checking if a certain file exists or not. In this case, it's a README file. So does a README file exist? It does. So in this case, in this very job that we see on the screen, it did exist. So the test case passed. So it did successfully complete and it triggered the next part of the process. The next part of the process is the CD part. As we have discussed previously, it is the CI/CD pipelines. So the CD part would be the deployment part of the process, which takes the artifact that we created in the first stage and it deploys it to the end systems. And the end systems in this case is we are deploying it to an S3 bucket, which you can see on the screen here. It's a simple S3 bucket. And what we are doing is we are taking the 3 or multiple files that we want and we are packaging them in stage 1 and we are making them available in this S3 bucket. And this was the deployment that we had done in the past. So we see the files exist. So now let's take a look at the code. this case, this is the workflow file for that. As we see, let's make it a little bigger. As we see, the file, this workflow only gets triggered if we push changes to main or master branch, and upon that happening, it would trigger the first job, which is CI build job, which checks out the code, and then it creates an artifact, makes it available in artifact. In this stage, it makes it available as an artifact in GitHub Actions. Right? Once it completes, we have explicitly listed so that we need the CI build job to successfully complete to trigger the testing part of the process. Because if that fails, we just want to stop the pipeline, because it's no point in testing anything at that point, right? So we have a build part of the process, and the build process part of the process successfully completes, and we have dependency on that. And then we go ahead and start testing if the build if what we created is successful or not. So in this case, we checked if this file existed. It's a simple use case. It does exist. Okay, let's move on. So we test for README file here. If it does exist, then successfully complete this job. Move on to the next phase, which is the CD process, which depends on CI test. If CI test fails, we'll run the use cases, both the use cases after this, to see how it successfully completes and how it fails as well. And the CI test phase would be a dependency, and it completes. Then we download the artifact that we created in the build process, and then deploy it to AWS using the S3 or AWS CLI. And upon that, we see a file here in readme.md. And to look at that file right now, if we open that file, we see this is how the file looks like, which is what is very similar, exactly identical to what is in our code repo, which we are going to change right now. So let's try and do that. So let's leave the actions here. And go and simply make changes to our README and trigger the pipeline. This is a new line. It's not really ideal. It would be a great thing to create a pull request, get it reviewed, merged it, and then that would be triggering the pipeline. But in this case, we're just gonna commit the change. So I'm gonna commit the change. So this is very similar to what we discussed, which is I'm making a change and applying that change to the main or the master branch or the default branch. This is exactly what I'm doing right now. So commit that change. We should see something here. We should see the pipeline getting triggered because we have made the change to the default branch, and it gets triggered. So this is the new run for that pipeline. So right now it is executing the CI build part of the process. So we'll wait for that. We'll take a look inside. It's successfully completed. Now we can see it's running the CI tests. We take a look at the testing. It's executing it, and it says, all right, we do exist. The file exists. The ones that we're looking for. The test case is successfully completed here. This is a CI test part of the process, and it's doing the deployment now. So we created an artifact. It was tested successfully. Now we are doing the deploy, and it was deployed successfully too. So what do we expect? What we expect now is we made a change to this file here and said this is a new line. The file in S3, which is going to be the deployed artifact, should have that change now. I'm just going to refresh my screen for good measure. This was how the file looked like previously. I don't know, I could refresh it, but I'll just open it again. All right. We see the change has been successfully deployed and applied to our end target environment here. So this is a successful run of a CI/CD pipeline. Let's try and intentionally fail the pipeline. How would we do that? We have a test case which we have as a gatekeeper, as a buffer, so that if the tests fail, we don't really want to deploy it any further, right? That's why we have those dependencies that we've had. So the test in this case is going to look for is the README file exists. So we're going to delete that file. We can add that later. So I'm just going to delete this file. Commit the change. Okay. So I've committed the change again to the master branch. In this case, there's no README file now, as you can see. So I should see a new job getting triggered here. we see a new job getting triggered, the CI build process. It is supposed to succeed. CI test has to fail. Okay. Error. Test case fail. So what happened here? We didn't execute the CD process. This job was skipped because our test failed. Our build process failed. Then the CI test would have not executed. It's in a very similar way. So this is a very simple example of how CI/CD pipelines would run in a very complex environment. We make changes to the master branch, and we let the pipelines or our workflows to build and deploy take over. And in this case, we saw how we could successfully deploy it, and we can have test cases as gatekeepers and barriers to make sure error-erroneous code doesn't end up going in production. Thank you so much for watching.